So we have a problem on dimensional analysis. The problem says that there is a model wind turbine with the diameter of 90 centimeters, the rotational speed of 1200 RPMs, and power is 280 watts, and the velocity of the wind is 12 meters per second. Okay, this power is at this wind speed. And then we have the prototype diameter, which is 50 meters, and the wind velocity at 8 meters per second. It says what is the omega, the rotational speed of the prototype, and the power of the prototype. So we will always assume that this prototype and the model is similar. Okay, so first, before we start the solution, I will try to generate the non-dimensional numbers and then apply to the problem. So I will say that the step 1 will be generate the pi. Okay, the pi's means that the non-dimensional numbers. So then I need to write the unit of each variable. So the first, we have the power of the wind turbine, and this one is function of the velocity of the wind, the rotational speed of the turbine, the diameter of the turbine, and the density of the air. Okay, so in this problem we will say that the densities are equal. Okay, that's a good side for the problem. But for the power, it is a function of the wind speed, the rotational speed of the turbine, which is very clear, the diameter of the turbine, because more diameter means that more mass flow of the air, and then the density of the air, because if air is dense, then you can get more power. If air is less dense, then you can get less power. Okay, so then power, the velocity, the rotational speed, diameter, and then density. Okay, this one has a unit of meters per second, or the dimension of length by time. And this one has unit of the revolutions per second. Where is that? Revolutions per minute or revolutions per second. And this one at the end, revolutions don't have any dimension, so you will have the time only. So it will be 1 by time. The diameter is the length, density is the mass by volume, so you will have the mass by the length to the power of 3. And then finally, the power. You can find the power by using energy per time. Okay, or force into velocity. So I will use energy per time, force into velocity. Both are okay. So force into velocity. Okay, force is mass into acceleration. So this one is mass into acceleration, and then you have the velocity. So you will have the mass. The acceleration is the length by time squared. The velocity is length by time. Okay. The total is that you will have mass, and then length squared by time to the power of 3. That is for the dimensions. So we have almost the most fundamental step ready. Okay, then we will go to the next step, which says that we will choose our repeating parameters. Okay, so we will choose the parameters that we want to be in every pi. Okay, or you can say that the parameters that we care the most, that we see that it is the most important one. So we cannot choose this one as a repeating parameter because this one is a dependent variable. Okay, so This one, no. So we have 4 of them, okay? But we have to know how many repeating parameters do we need before we move on. So we have 3 primary variables. In the problem, you can see we have the length, we have time, and we have mass. Okay? That means that we will need 3 repeating parameters. Okay? So as we said, this one cannot apply because this one is independent parameter. So then we will look for the velocity, this one, the rotational speed, then the diameter, and then the density. Okay? And the rules that we know, we can choose any 3 of them, okay? Because there is no something that violates the rules for choosing the repeating parameters. Only problem is that so we cannot choose velocity, omega, and then d. Okay? The reason is omega d combination by velocity creates a non-dimensional number. So omega d by velocity is non-dimensional. Okay. That is the reason that we cannot choose. Okay. The rest 3 we can choose. But what I will do is that I will choose this one because this one has a mass in it, which is good to have a different parameter, okay? Because I want one to include mass, one to include the length, and one to include the time, okay? That's what I want to do. The length, this one and that one also includes, so I will choose this one, the easier one. This is my second repeating parameter. Then I can either choose the velocity or the omega, okay? Both are okay, but I will choose this one. You can also choose this one, okay? You will not get a different answer. So I have first repeating parameter and second one and then third one. Next step is that we will generate our non-dimensional numbers. Okay, so let's do that. So now the time is to generate the non-dimensional numbers. The first one is that we will just put the repeating parameters with the unknown exponents of a1, b1, and c1. We will just write the remaining variable here, either work power or the velocity. So first, the power, it will be that mass, length, and then time to the power of 3. Okay. And this one, and that one, and this one, and that one, all of them should create a non-dimensional number. In other words, this one has an exponent of 1. Okay. So this 1, a1, b1, and c1, all the exponents combined together should create a non-dimensional number. So let's see how it works. So first, we will write the equation for the length. Means that 2 times 1 plus, there is no length here, so length is here, 1 into b1, and then negative 3 into c1. This one should be equal to 0 because it has to be non-dimensional. So length should cancel out from the equation. Second one is that the time. So you will have the negative 3 here, and the negative 1, and then a1. So that's all. It should be equal to 0. Okay. And the last one is for the mass. So we will have the mass. So it has a 1, and then mass here as well, 1, and then to C1. that will be equal to 0. So if you solve it, so C1 should be -1, A1 should be -3, and then B1. So since C1 is -1, so we have 3 here and 2 here, it makes 5. So B1 should be -5. Okay. If we combine it all together, so we know that this one is work dot, and we know that this one is omega, and this one is the diameter, and this one is the density. Okay, so our first pi1 will be that the power omega, which is A1, and A1 is -3, should be the omega to the power of 3, and D is B1, and B1 is -5, so it will be that D to the power of 5, and the rho is C1, and C1 is -1, it should be that rho. Okay, that is the first pi. Okay, then we will now generate the second pi, which is very similar to the process of pi1. So let's do that. So it is very similar to the process of pi1, so we will do that. So let's do it. So you will have the pi2. Instead of power, I will have the velocity, and then again 1 by t, this time exponent a2, length with exponent b2, and then density with exponent c2. Okay. So let's solve it. So first for a length, so it is 1, so it is 1 again b2, -3 into c2 is equal to 0. Time, so -1, -a2, and then 0, and then the mass is C2 only, which is 0. Okay, from here it follows that C2 is 0, A2 is 1, and then 0, and B2 is -1. Then pi2 becomes the velocity times, so sorry, A2 is -1, so A2 should be -1, so velocity by omega into the diameter, okay, which is the omega r. So this one just has a coefficient of 2, so the one that we know from tangential velocity. Okay, so we have 2 pi's. So now we will say that the pi1 is same for model and prototype, pi2 is same for model and prototype, and then we will solve for the unknowns.